Hey guys, so we're going to move on to the next lesson, which is lesson 6.4. Let me present my screen and we'll get started. So in this lesson, we're going to be talking about indirect proofs, and we're going to be talking about, oh, I'm sorry. Hold on 1 second. Yes. Indirect proofs and triangle inequalities in one triangle. It's in the wrong spot in my notebook, but now we're all together. All right. So why is that flashing? Okay. So writing an indirect proof. Suppose a student looks around the cafeteria, concludes that hamburgers are not being served, and explains as following. At first, I assumed that we are having hamburgers because today is Tuesday, and Tuesday is usually hamburger day. There is always ketchup on the table when we have hamburgers, so I looked for the ketchup, but I didn't see any. So my assumption that we're having hamburgers must be false. All right, so here it says the student uses indirect reasoning. In an indirect proof, you start by making the temporary assumption that the desired conclusion is false. By then showing that this assumption leads to a logical impossibility, you prove the original statement true by contradiction. Okay, I know it sounds confusing, but we're going to go through an example. And then if you go back and reread that, it'll make more sense. All right. So there are steps that we're going to follow. The first step is to identify the statement you want to prove. Assume temporarily that this statement is false by assuming that its opposite is true. And then second step, reason logically until you reach a contradiction. Third step, point out that a desired conclusion must be true because a contradiction proves the temporary assumption false. All right, so we're going to write an indirect proof. It says write an indirect proof that in a given triangle, there can be at most one right angle. So you're given triangle ABC, you want to prove that triangle ABC can have at most one right angle. Okay, so let me move this up just a bit. All right, get my pen. I'm going to break this into the steps that are listed above so that you can refer to them. The first step that I read above said that you're going to identify the statement you want to prove. Well, that's right here. It says prove that triangle ABC can only have at most one right angle. And then after you identify that, you're going to assume temporarily that this statement is false by assuming its opposite is true. So the opposite of a triangle having at most one right angle would be triangle ABC has two right angles. All right, so that's what we're going to say. We're going to say assume temporarily that triangle ABC has two right angles. All right. Step 2 says to then reason logically until you reach a contradiction. Okay. So we know that right angles have a measure of 90 degrees. So I'm going to say the measure of angle A equals 90 and the measure of angle B equals 90. I could have picked B and C or A and C. It doesn't matter. Just pick two angles and say they're both 90 degrees. And that's based on the definition of right angles. Okay, right angles, 90 degrees. Then from there, I know that the three angles of a triangle have to add up to 180 degrees. So the measure of angle A plus the measure of angle B plus the measure of angle C equals 180. And how do I know that? That's from the triangle sum theorem. Then I can use substitution. If angle A is 90 and B is 90, I can say 90 plus 90 plus the measure of angle C equals 180. That was based on substitution. All right, adding like terms, 90 plus 90 is 180, subtract to the other side. So I'm going to have the measurement of angle C equals 0 degrees by subtraction. All right, at this point, you can stop. You've reached your contradiction. You cannot have an angle in a triangle that is 0 degrees. It's not possible. So we're going to say you cannot have a 0 degree angle in a triangle. That's an arrow. That's just a really bad arrow. This is the contradiction. All right. So that leads us to step 3. Step 3 says, point out that the desired conclusion must be true since the contradiction proves the temporary assumption is false. So I just proved that triangle ABC cannot have 2 right angles, right? Because I came up with a contradiction. Therefore, using indirect proof, I proved that triangle ABC can have at most 1 right angle. So I'm going to say, so the assumption that triangle ABC has 2 right angles is false, which proves that triangle ABC can have at most 1 right angle. Okay, so that is angle. Erase that little dash mark. That is a proof by indirect, or that is an indirect proof. Okay, let's move on to the next example. All right, the next one, we're going to sketch. It says, draw an obtuse scalene triangle, find the largest angle and the longest side. Okay, so I'm going to draw it in black because then it tells us to highlight things in red and blue. So I'm going to start with a small segment, and then I want a big obtuse angle. Oh, you know what? I want to try to draw a little nicer. Small segment, then a big obtuse angle, and then I'll close my triangle. Okay. All right. So I did not draw that very well, honestly. That's okay. We'll just deal with it. It says find the smallest, or excuse me, first it says find the largest angle and the longest side. Well, this is my obtuse angle. So this is my largest angle. And then across from that, this side is the longest side of the triangle. All right. Then it says find the shortest side and the smallest angle. Well, this is the shortest side. We're supposed to highlight it in blue, but I don't have a blue pen to use, so I'm going to use yellow. And across from it, and that's why I said I didn't really draw this really well, because I don't know, I think almost this angle looks smaller than that one, but it's because it's a bad sketch. This is actually the smallest angle of the triangle. So what conclusion, what observation can we make? Well, it appears that the longest side and the largest angle are across from each other, and the smallest angle and the shortest side are across from each other. Okay, so that's the observation we're going to make. The largest angle is opposite the longest side. And the smallest angle is opposite the shortest side. All right. So that leads us into our next 2 theorems. Let's scroll down and see what they say. Okay, so first off, it says here, the relationships in example 2, the relationships we just came up with right up there, are true for all triangles, as stated in the 2 theorems below. These relationships can help you decide whether a particular arrangement of side lengths and angle measures in a triangle may be possible. Okay, so we have two theorems. It's called the triangle longer side theorem and the triangle larger angle theorem. Okay, so it says here if one side of a triangle is longer than the other side, then the angle opposite the longer side is larger than the angle opposite the shorter side. So if you're given two side lengths of a triangle, or even three, we're actually going to do problems where we're given all three side lengths, you can figure out what angle is the largest angle, which angle is the smallest angle, which one would the medium angle be. Okay, in this case I only have two side lengths to choose from. AB is 8 and BC is 5. All right, 8 is bigger than 5, so the angle across from it, angle C, is going to have a greater measure than the angle across from the 5. So although I don't know the actual angle measurements, I can make a conclusion and say that the measurement of angle C is greater than the measurement of angle A. Or if you want to start with angle A, you would say the measurement of angle A is less than the measurement of angle C. Okay, so that's based on the triangle longer side theorem. Now we can use the angles to make a conclusion about the sides. All right, if this angle is 30 and this angle is 50, the smaller angle is going to be across from the shorter side. This side is going to be shorter, and 50, this side is going to be longer. So if I wanted to compare the two side lengths, I can say that AB is shorter, is less than BC. Or again, if you want to flip it around, you could say that BC is going to be longer. It's going to be greater than AB. Okay. So let's flip the page. We're actually going to skip example 3 and go right to example 4. So skip on over 3, go to 4. Okay, so for this one, it says list the sides of triangle DEF in order from shortest to longest. Well, if you know two angle measurements, we can figure out the third. So let's do that, because if we want to compare all three side lengths, we need to know all three angles. All right, so I know that the measurement of angle D plus the measurement of angle E plus the measurement of angle F equals 180. And I'm sure you can just quickly do this in your head or on a calculator. 51 plus 47 plus the measurement of angle F equals 180. Add and subtract, and you're left with the measurement of angle F is equal to 82. Okay, so I figured out this was 82. Now, the reason I want to know all three angle measurements is now if I'm going from shortest to longest side, I want to find the smallest angle. This is the smallest angle. This is my middle or medium angle, and this is the largest or biggest angle. So the side across from the smallest angle is going to be your shortest side. That's my short side. The one across from 51, because that's the middle value, right? The middle angle size. This is going to be the middle side length. That one's going to be in the middle. And then the largest angle is across from the longest side. Ordering the sides from shortest to longest, because that's what the directions say to do, I would say that DF is less than FE, which is less than DE. Okay. Now that's using inequality symbols. You could also, depending on the instructions, if I don't for you to use inequality symbols, you could also write that segment DF, just list them, segment DF, comma, segment EF, and then comma, segment DE. So that would be like listing the segments from shortest to longest. And this is writing it as an inequality. Notice with the inequalities, we don't put the segment bars over top because we're talking about the distance, the length, the numerical value. Okay, so that is example 4. All right, let's move on. Using triangle inequality theorem. Not every group of 3 segments can be used to form a triangle. The lengths of the segments must fit a certain relationship for the 3 attempted must fit a certain relationship. For example, 3 attempted triangle constructions using segments with given lengths are shown below. Only the first group of segments forms a triangle. So you can see here we have side lengths 5, 4, and 2. And when you take the 3 segments and try to form a triangle, it does form a triangle. Here I have a segment of length 5 and then 2 and 2. And the red arcs, what they're showing, like they're showing that if you move those segment lengths of 2 down towards each other to try to meet, right, to try to meet at a vertex, they're never going to meet. Okay, they're going to flatten down because they're not long enough. They're not going to meet. So a triangle is not going to be formed. And the next one as well, 5, 3, and 2. If you take the 3 and the 2, the red arcs are showing you as you bring them down. All right, they're going to meet, but not until they're parallel with the other segment. So you're not going to have a triangle. You're going to have two segments that are just parallel to each other. I typically, if we were back in the classroom, what I would do, and if you want to try this on your own at home, you can. I typically hand out a piece of pasta, like spaghetti, linguine, something like that, long piece of pasta. And I tell all of my students, break it into 3 pieces. All right. And a lot of people will break them all into relatively the same size. And then I say, okay, now form a triangle. All the endpoints of the pasta have to meet and form a triangle. You always have one student there. There's always one. Someone will leave the piece of pasta super long and then like 2 teeny little pieces of pasta, and they'll be trying to form a triangle and they can't. And it's because of this special relationship that we're going to talk about here. All right. The 2 smaller pieces always have to add up to be longer than that third piece. So if you have a really long piece of pasta and 2 teeny ones, the 2 teeny ones don't add up to a greater value than the long one. So a triangle can't be formed. So if you think about what I just said, the 2 smaller pieces, in this case, the 4 and the 2, if you take 4 and 2 and add them together, you get 6. That is bigger than 5. So it's going to work. The 2 smaller pieces, they add up to a 4. It's not greater than 5. So this one's not going to work. The 2 smaller pieces add up to a 5. It's not greater than 5. It's not going to work. So the 2 smaller ones always have to be greater when you add them together, have to be greater than that third side. All right. So that's what this all says. Let's move down to the theorem. It's called the triangle inequality theorem. And this is exactly what I just said. The sum of the lengths of any 2 sides of a triangle has to be greater than the length of the third side. So what they're showing here with the 3 different inequalities is if you take the pink, or not pink, the red and the blue and add them together. Okay, think about even just flattening them out, making them into one long segment. The red and the blue are greater than the green. The green and the blue added together will be greater than the red. And the red and the green added together will be a greater length than the blue. Okay, now the trick is you really only need to check the 2 smaller segments. Okay, but you could check all 3. All right, so the next problem is going to be example 5, finding possible side lengths for a third side. So to do this, if you're given a triangle has length 14 and 9 and you're asked to describe the possible lengths of the third side, I don't want just like one example. I want all the possible lengths, right? Like you could kind of do guess and check and say, all right, maybe it's 10. Okay. Take the 2 smaller lengths. Do they add up to be greater than 14? Yeah. So this other side length could be a 10, but it could be a lot of different numbers, right? Like maybe I'm going to say it's an 11. If you take the 2 smaller 11 and 9, add them together, is it greater than 14? Yeah. So we could have a third side of length 11. But again, there's multiple answers. So how do I find them all? Well, you take the 2 values that are given. You're going to find the difference of them. You're going to find the sum of them. And the third side, which we're going to call X. Oh, I'll write the words third side for now. The third side is going to be a number between the difference and the sum. It's going to be a number that's greater than the difference, but less than the sum. Okay. So again, the difference 14 minus 9 and the sum 14 plus 9. All right, the difference is going to give you a 5. The sum is going to give you a 23. So that means the third side, which I'm going to use X for, the third side is going to be a number between 5 and 23. It's going to be a number greater than 5. And when I say a number greater than 5, it could be 5.1, 5.2, 5.3, right? and a number less than 23. So it could be like a 20, a 21, a 22, or it could be a 22.9 because fractions and decimals will work as well. Okay. But if we're just talking whole numbers, that means that the third side could be a 6, a 7, an 8, a 9, a 10, an 11. I showed you 10 and 11 worked, right? A 12, a 13, anything up to 22, where, like I said, like 22.9 will work as well. Okay, so those are the possible third side lengths. All right, I think I just want to show a few quick examples on the extra practice, just for a few more examples for you to go off of. Number 6, you're given the 3 side lengths. You're asked to list the angles from smallest to largest. So find the shortest side. I'm going to just label it with an S, the longest side, and the middle side. The shortest side is going to be across from the smallest angle. So the measurement of angle C is the smallest. It's less than, then go to the middle. That's across from A. So the measurement of angle A would come next, and that's less than. The biggest angle is across from the longest side. So that's going to be angle B, the measurement of angle B. Again, if I wasn't asking for you to write it in inequality form, you could just say angle C, comma, angle A, comma, angle B. Okay, listing the angles from smallest to largest. All right. Let's look at 9 through 12 because they're pretty quick problems. Here it says, is it possible to construct a triangle with the side length? So this is where you can like try to visualize a segment 17 units long and 12 and 3. Could you make the 12 and 3 meet to form a triangle, or would they not meet? Would they never touch, or would they be parallel? So again, the trick is take the two smaller sides, add them together. So 3 plus 12, that adds to 15. This sum has to be larger than the third side. Is 15 larger than 17? No. So no triangle. Okay. Now I'll do the other one out a little bit more formally. So the smaller two sides, 5 plus 16, have to be larger. So that has to be greater. I'll put a greater than with a question mark over top of it, 21. All right. So 5 plus 16 is 21. Is 21 greater than 21? It's not, so no triangle. Smaller two segments, 5 and 7, when you take 5 plus 7, they have to be greater than that third side, which is an 8. All right, so 5 plus 7 is 12. 12 is greater than 8. So yes, we have a triangle here. Smaller two sides, 10 and 3, when you add them together, it has to be greater than the third side. 13 is greater than 11. So again, yes, we have a triangle. All right, the last problem for tonight or today, whatever time you're watching this video, it's nighttime for me. It says a triangle has two side lengths of 5 and 13. Describe the possible lengths of the third side. Again, I'm not just looking for one example because yes, you could do some guess and check. I want all of the possibilities. So I want you to write it as an inequality. All right, so this is where you're going to find the difference. And you're going to say the third side is less than that difference, but greater. Oops, sorry. Put the inequalities in the wrong direction. Third side is, no, I didn't. Sorry. I don't know if I did. I don't remember what I just wrote. The third side is greater than the difference, but the third side is less than the sum. All right. So it's going to be 13 minus 5 for the difference, 13 plus 5 for the sum. And you're saying your third side has to be a number in between those two. So you get an 8 is less than x, which is less than 18. All right. All right, guys, that is it for lesson 6.5. I'll see you back here for the last lesson of the chapter. Bye.